This is Unit 6, Video 7, Practice with Heating Current. What we're going to do is we're going to take lead and look at the values given for lead. And we're going to do a heating current calculation of lead. So we've got lead here. The melting point of lead is 327.5 degrees Celsius. The boiling point is 1,749 degrees Celsius. The three heat capacities are given. You notice I've given the heat capacity in both gram and mole. Gram, mole, gram, mole. It shouldn't matter which way you do it. It just depends on how the information is given. And then for our phase changes, we have the heat of vaporization, 178 kilojoules per mole, i.e. it takes a lot of energy to vaporize lead, very heavy atoms. Heat of fusion, though, is a much smaller 4.77 kilojoules per mole. So not a lot of energy to melt, a lot of energy to vaporize. All right, so what we're going to do is we're going to calculate the heat involved to change 50 grams of lead from 25 degrees Celsius to 500 degrees Celsius. Okay, so that's what we want to do, is calculate the heat change. To do this, first we want to do is look at our heating curve. So here's a little pre-set up heating curve. And let's pick our starting point, 25 degrees Celsius. Now 25 degrees Celsius, since the melting point of lead is 327, that's solid lead. Then we're going to 500 degrees, so this is solid. We're going to 500 degrees. 500 degrees is above the melting point but below the boiling point. So if it's above the melting point, it's a liquid. If it's below the boiling point, it's a liquid. So this is a liquid. So we're going from somewhere in the solid through the melting point to the liquid. We're going to have three calculations here. So let's do it up here. We're starting at 25 degrees Celsius. 25 is going to be, this is 500, so we're going to 500. Obviously, this would be 100, 200, 300, 400. Okay, so we're starting about right here. We're going to heat until we reach the melting point. At that point, obviously, we're going to melt. So the melting point is 327.5, so it's somewhere about right there. So we're going to heat until we reach that melting point. At that point, all of our energy is going into melting. Then we're going to heat to 500. So this calculation is warming the solid. That's a heat capacity calculation. Q equals Cn delta T or Sm delta T. Depends on whether we want to do it in grams or moles. This here is a phase change. Phase change is governed by heat of fusion. So we're going to have Q equals the heat of fusion times the number of moles. Here we have solid lead at 327.5 degrees Celsius. Here we have liquid lead. All we've done is added heat. We have not changed its temperature. Then we're going to go through the final phase, which is taking liquid lead and heat it to 500 degrees. So we're back to Q equals Cn delta T as we warm the liquid. Okay, so let's do those three calculations. The first calculation is taking the solid from 25 degrees Celsius to 500 degrees Celsius. Okay, well, we know that calculation. That is Q equals Cm delta T. We're going to need the moles present here for 500 or 50 grams. So 50 grams of lead, and we'll just do a little side calculation here. 1 over 207.2 is equal to 0.249. 0.241. 0.241 moles. So there's our moles. So Q is equal to the heat capacity of the solid. So I'm going to go over here and find the heat capacity of the solid in moles, 26.5. So 26.5 joules per mole degree Celsius times 0.241 moles times, and this is a continuation, the melting point minus the original. So 327.5 minus 25. Plug that into our calculator, and the first Q, we'll call it Q1, equals 26.5 times 0.241 times this difference, which is 302.5, is going to give me 1,930 joules, which I'm going to go ahead and convert that into kilojoules, 1.93 kilojoules. The second step is the melt. Melt, there's no temperature change occurring whatsoever. We're sitting right at 327.5 degrees Celsius. So we've got Q equals the heat of fusion times the number of moles. Heat of fusion for this is 4.77. So 4.77 kilojoules per mole times 0.241 moles. Plug that into the calculator, and you're going to get 1.15 kilojoules. So Q2 equals 1.15 kilojoules. Now, once we've melted it, we're sitting right here on the end of the line here. We've got liquid lead, molten lead. So we're going to take that liquid lead and we're going to raise this temperature to 500 degrees. But remember, the starting temperature here is the melting point. So we're starting at 327.5 and going to 500. So my third one is liquid. Q is going to be equal to Cn delta T. So I need the heat capacity of the liquid. In grams is 0.14, in moles is 29.0. So I have 29.0 joules per mole degree Celsius times 0.241 moles times temperature change 500 degrees minus 327.5. 327.5. All of that equals 1,210 joules, or 1.21 kilojoules. So my Q3 is 1.21 kilojoules. Well, our total heat, we're calculating the total heat to go from 25 to 500. And so our total heat is going to be 1.93 plus 1.15 plus 1.21. Add those up, and I get 4.29 kilojoules. And that's the total heat involved in taking lead from 25 degrees Celsius to 500. 3 individual steps.